My fabulous chemistry faithful video number 9, retake number 1. Hopefully this records this time. All right, last video of the unit, combined gas law. There's a big bad equation we got to get through. Okay, this is a great picture just to show you mentally about what's about to happen. The whole before and after for specifically sealed containers. If I heat it up, the particles start moving faster. That's the first two pictures. If I decrease the volume, the particles are going to get closer together, hence more pressure. If I increase the volume, the pressure, or if I increase the pressure, the volume is going to increase, that kind of thing. So these are the before and after using what we learned in the last video about the relationship. Well, it turns out Charles' law, Guy-Lussac's law, and Boyle's law are the three laws that we learned about on video 8. Those two direct and one indirect relationships. Those are three different laws made by three different guys, and you put them all together and you get this big bad boy. This is called the combined gas law. P1V1 over T1 equals P2V2 over T2, where 1 is the initial set of conditions, 2 is the final set of conditions. And we just basically going to give you 5 variables. You're going to plug and chug and do some regular math. Okay. Only stipulations. Temperature must be in Kelvin, period. Cannot have 0 as a denominator in a fraction. So Celsius will not work. And then the other volumes for pressure and for volume, the other variables, the units on the other variables for pressure and volume can change. They can be atmospheres. That's fine. They can be pascals. That's fine. But the rule is if I'm initially in pascals, I have to be in pascals when I'm done. And if I'm initially in atmospheres, I need to be in atmospheres when I'm done. If the volume is in milliliters, then it's going to be in milliliters when I'm done. And they just have to jive. As long as they jive on both sides of the equation, we all set. So one solid example for us to get through, and then you're off to the races. So here's our equation, P1V1 over T1 equals P2V2 over T2. I am going to pull these variables out, not in the order that they're given in the problem, which is what you want to do. You can do that as long as you match them up properly. I'm going to pull them out based on what the equation's asking for. So it's going to ask for P1, then V1, then T1. So I'm going to go in that order. This whole first statement, it turns out when you read it, is the initial set of conditions. It says a gas has a volume of 20 milliliters at temperature 298 K and a pressure of 101.3 kilopascals. What will the new volume be if the temperature is changed? The temperature is changed. That's the final, right? That's going to be the T2. And the pressure changed. Well, that's going to be P2. So the first three numbers are the initial sets. And it turns out the last number given is pressure. That's the first number we need. P1 is 101.3 kilopascals. V1, milliliters, is volume. This is things that you guys need to know at this point in your scientific careers. Temperature of 298 K. 298 kelvins is temperature, T1. Got it? Now, P2, pressure change to. Temperature change to. But, I need new volume. I don't know what that volume is. That's my variable. And then temperature change to 323. Now I have all of my variables labeled up. Now I just plug and chug. So P1 times V1 is 101.3 times 20 divided by T1, 298. This is me plugging in the numbers, equals P2 times V2. So that's 50.65 times X divided by 323. Now with this math, because there's an equal sign, I cross multiply. So I do 101.3 times 20 times 323. All in my calculator, I'm going to get a number. And you'll see that the number is going to come up here. And then on the other side, I do 298 times 50.65 equals. That's going to give me, this is the answer for 101.3 times 20 times 323. That's going to equal 298 times 50.65 times X. Divide both sides by this 15,093.7, and you get 43.4 as our answer. So it's one example in the video. The rest of these examples, I'm going to give you a variable of some sort that you have to find. If I tell you it's at standard temperature and pressure, you know the numbers for standard temperature and pressure. 273 kelvins is 0 degrees Celsius. And pick one atmosphere because this is 101.3 kilopascals, but 101.3 is a lot harder to deal with than one atmosphere. If I can pick atmospheres, do that. Definitely make your life easy. It's easier to multiply and divide by 1. Make your life easy. So if you see something hidden as standard temperature and pressure, you're given those numbers. You don't just get to say, oh, I don't know what those are. You do know what those are. Front page of your reference tables. And with that, we just got practice to do and check your answers.